Alright friends, we are now all set to finish off this chapter. In the last unit, we discussed how to identify rational and irrational numbers. We also discussed how to tell whether a given fraction will result in a terminating decimal. In this last unit, we are going to prove irrationality of a number. So let's do that. But before we head to prove irrationality of a number, we need to know a small theorem. So let's discuss this small theorem first. Consider any positive integer a. Let's say a is composed of prime factors p1, p2, p3, etc. till pn. What does it mean? It means that each of these prime numbers, that is p1, p2, p3, etc. till pn, will divide a. Now let's write this formally. So we can write a as a is equal to p1 times p2 times p3 times etc. till pn. Now squaring this equation, we get a square is equal to p1 square times p2 square times p3 square till pn. Now what do you observe here? We can see that even a square has only prime factors p1, p2, etc. till pn. So what does it mean? It means that if a has prime factors p1, p2, p3, etc. till pn, a square will also have the same prime factors p1, p2, p3, etc. till pn. Now the converse of this statement is also true. Now what is the converse of this statement? If p1, p2, p3, etc. pn are prime factors of a square, then p1, p2, p3, etc. pn will be prime factors of a as well. That's the small theorem that we wanted to discuss. Let's state this small theorem a bit more formally. In general, we can state this small theorem as if a prime number p divides a square, it will divide a as well. It's as simple as that. Now let's move on to prove irrationality of root 2. The method by which we are going to prove that root 2 is irrational is known as proof by contradiction. Now this is very interesting. To prove root 2 is irrational, we will start by stating the contrary. And what is the contrary? We will assume that root 2 is rational. Now what does that mean? It means that root 2 could be expressed in the form of p by q. Now think that p and q have some common factors, and we are going to reduce it by cancelling off the common factors in the numerator and denominator. And let's say that we got the reduced fraction as a by b. So we can write root 2 as root 2 equals a by b. In other words, we can write it as a equals root 2 times b. Now what happens if we square it? We will get this as a square is equal to 2b square. And then you will get the reduced fraction as a by b. Now done clearly that a and b does not have any common factor between them. This is why we call a by b as the reduced fraction. So in other words, we say that a and b are coprimes. What do you mean by coprime? Coprimes are numbers which do not share any common factors other than 1. Alright, now we have reduced p by q to a by b. This means we can write root 2 is equal to a by b. Rearranging it, we can write a is equal to b root 2. Now let's square this equation. So we get a square is equal to 2b square. What does it mean? It means that 2 divides a square. Now remember the small theorem that we just discussed? If 2 divides a square, it means that 2 divides a as well. It means we can write a as some 2 times c. Now that we got 2 divides A, we can simply write A as 2 times C, where C is some integer. Substituting this result, that is A equals 2C in equation 1, we get 4C square equals 2B square. Reducing it further, we can write 2C square equals B square. Now, what does this equation mean? It means that 2 divides B square. Now, from the small theorem, we can say that if 2 divides B square, 2 divides B as well. So, initially we got 2 divides A and now we are getting 2 divides B. But how come? We already stated that the reduced fraction A by B, that is A and B, will not have any common factors. But now we are getting 2 as the common factor. Isn't it strange? It means that our initial assumption that root 2 is rational was wrong. This is how proof by contradiction works. To prove irrationality of any number, you can use this method. So that's it. We have now come to an end of this chapter. I hope all of you have clearly understood the concepts and processes that we have explained in this entire chapter. If you have any doubts, please feel free to use the doubt section to clarify your doubts. We will be happy to help you. Happy learning!